Hello, in this video we are going to work on answering the question, what is a limit? We are going to approach it from a graph perspective in this video, and then later on we'll start talking about how we can get to limits from equations. Sometimes limits are confusing, but I think and I hope that the way that I present it here, it'll make sense. What I would like you to do before we even start doing anything is find some values, and I'd like to explain a little bit about this graph before we go. You can see that it's made up of a bunch of different pieces. This is a line, this is a curve of some sort, there's a line, this is a line, and then a line there. You can see that there's a solid spot there and an open spot there. That tells me that the function is this at this x value, not there at that x value. Similarly, you can see there's like kind of a spot here. So it comes in close to a height of 1 there, but the actual value at that spot is this right here, which is 5. Is that right? And then same thing over here. It comes in, but it doesn't actually hit that spot. Remember, we have that thing called the vertical line test. So if I had a solid dot here and a solid dot here and one there, this thing would not pass the vertical line test, and therefore it would not be a function. So, enough talking. What I'd like you to do is press pause and then find these values all right here. So press pause. Here come the answers. So hopefully you've done them. All right. So we got 0, 3, 6, -2, 5, 3, and 3. Let's go over those briefly. F of -8 is, if I go back to -8 here, we're there. Notice the height there is nothing, is 0. So f of 8, -8 is 0. That's this height right here. Next, I've got f of -5. So I go back to x equals -5 and then go up to where the function is. Boom, right there. That's 3. Next is f of -4. So I go back to -4 and then I go up to where the function is. I pass through there because of the open circle. Pass through there. Boom, it's this right here. And that height is 6. Next one, f of 0. Well, I take the x value, sorry about that, of 0, and that gives me this right here. So the height is -2. At 3, we go out 3 units, and then I go up to the function. I pass through that, because the open circle, go up to here. This height is 5. F of 5. I go out to here, and then I go up until I get to the function. Boom, it's right there. It is 3. And lastly, f of 6. This one, the two that I think might have been most funky would have been this and this. So f of 6, I go out to x equals 6, and then I go up to where the function is. So you may say, well, which one of these do I choose? Do I choose the upper one, which is 4, or the lower one, which is 3? Well, notice that the lower one has that solid dot, so we're taking that right there. I guess there's one more thing that I should mention about this graph that I didn't before. Hopefully you picked that up, but you can assume these are straight lines, and that if it looks like it goes through a point, it does. I did put some dots in some places, but, you know, for example, it goes through that point right there. All right, so let's now talk about a limit. All right, so again, I've got this same graph right here, and now I'm going to introduce some new notation to you. What I'm going to do is write capital L-I-M. Underneath of that, I'm going to write x. I'm going to put a little arrow and write 0. And then I'm going to write f of x. And that's followed with an equal sign. So what do we see? What do we say when we read this? So the way we read this out loud, just like, you know, whenever you see this, you say f of x, right? Or if I wrote f open parentheses 3, we'd always read that as f of 3. So we have a specific way to read this new limit notation. The way that I read this is the limit as x goes to 0 of f of x. So I didn't write f of x because you should know how we pronounce that or how we say that out loud. So it's the limit as x goes to 0 of f of x. Say I had a 7 here, it would be the limit as x goes to 7 of f of x. Say I had a g here, it would be the limit as x goes to 0 of g of x. And I can introduce all kinds of other different things, but for now, we're just going to think about it as this new idea. So how do we calculate this? What we do. This right here is x equals 0. What I need to do is figure out what the function closes in around at that spot. So if you look here from the left, it's coming as we go into 0 on the x's, we are at a height of -2. If you look here, as we close into x equals 0 from the right side, again, we're closing into a height of 2. So we just say, of -2. So we just say that this is -2. Now, notice I did not say anything about what the actual height was at x equals 0. So let's see if we can do another one. Let's do the limit as x goes to, what am I going to do? 5 of f of x. So, again, we're using the same graph. What am I going to do? X here comes into 5, so I have to look at the green line as we go into 5 along that x equals, or as I need to look at what the green graph goes to as x goes to 5. So, again, coming up here, it is getting closer and closer and closer to this height. And then same thing here. As I come in from the right, we're also getting closer and closer to that height. So what I do is I look over here. That height is 3. So I get an answer of 3. One thing I want you to see, or one thing you might notice, is that this right here is just the value. Didn't we do 5? F of 5 was 3 before, right? So there's nothing different between what we've asked you to do so far and these limits. So with the next one, I'm going to show you something that is different. So, before I jump into what I'm going to talk about with the next one, I did want to specify, just by writing it out in case you want to write it down, that this right here, what is the limit as x goes to 0 of f of x? What it is, it's what we talked about over here. It's what the y value of the graph goes to, right? It goes to -2 from this side and -2 from this side as x gets closer and closer and closer to 0. So the next one that we're going to do is, we'll do the limits. We're going to look at what happens at x equals 3. So, the way I'm going to write this is the limit as x goes to 3 of f of x. So, let's zoom in a little bit here. And I'll make the pen a little bit smaller. So, what happens? This is x equals 3. Notice I'm coming in there, and I'm coming in here. Notice, it doesn't really matter that there's a little hole there. All I want to know is what does it get closer to? What does the height get closer to as the x gets closer to 3? So notice on the left side, we're coming into that height of 1. And same thing on the right side, we're coming into that height of 1. It doesn't matter what this actual value is. So since I've got both of them coming into 1, I can say that the limit as x goes to 3 of f of x is equal to 1. I hope that makes sense. You can see it's the same thing as the previous ones. Now, I want to point something out. We'll zoom out a little bit here. If I were to ask you what is f of 3, we did that earlier. Notice I don't take what it's going into. I take what it is when we go vertically up until, boom, we hit a spot. So that is 5. What I want you to see here is that the limit, and I'm going to be like not super formal with my notation here, the limit of f of x is not always the value. at f of x, right? So this would be the limit as x goes to 3, 1, but the value at x equals 3 is 5. So I hope that makes sense. What we're going to do next is I'll get another copy of this, and we'll do a couple more examples down below. Okay, so next we're going to do the limit as x goes to 6 of f of x. So one thing I want to say about a limit is it's like a function in that there's only one answer at any given time. So I can only have one limit as x goes to 6. I mentioned the vertical line test before. This graph over here is a graph, but it's not a function because it doesn't pass the vertical line test there and at many other spots. So I'll erase this. Let's do the limit as x goes to 6. So what I want you to see is that I'm going to go, this is 6 right here. If I come in from the left there, we go to this height. And if I come in from the right at x equals 6, then I go to this height. So what happens is that I have two conflicting answers, right? The limit as x goes to 6. Is it 4, the pink one, or is it 3, the purple one? And since I have two answers, what we say for this is that, that the limit, the limit as x goes to 6 of this thing, it does not exist. And oftentimes we abbreviate that as DNE. So why does it not exist? Because there's two conflicting values. But we can talk about one-sided limits. What I mean by that is I can talk about the pink limit and give it a value. I can talk about the purple limit and give it a value. So what I can say is that the limit as x goes to 6 versus, I'm going to do it in purple, the limit as x goes to 6. What I can do is indicate whether we're coming from the left or the right for a limit by putting a little sign. What I do is I put a negative sign for this, and I'll explain why, and a plus sign for this. The way I read this out loud, just like the way we read that out loud, is the limit as x goes to 6 from the left. And this is the limit as x goes to 6 from the right. So, as I come in from the left, what do we go around? This value, which is 4. So I say, I guess I don't have my f of x here, but the limit as x goes to 6 from the left of f of x is just what it goes into from the left side. So what do? I write a 4. And then the limit as x goes to 6 from the right of f of x is, well, what does it come into from the right side? It comes into 3. So it's okay to have different limits. We just have to specify, is it a left limit or a right limit? Now, the minus, we use minus for left limit because it comes from the, quote, negative side or from the, quote, positive side. So I'm going to give you 2 more to do here. Okay, we have blue, black, and red. 3 of them. So the limit as x goes to negative 4 of f of x. Well, notice this is negative 4 here, and it comes into one side. On the left side, it comes into one value, and on the right side, it comes into another value. So I write D, N, E. Next, in black, we've got the limit as x goes to negative 4 from the left. So I draw a little arrow from the left, and what height do we come into? You should see we come into that 4. So I say it's 4. The last one we have is in red, and it's the limit, right here, limit as x goes to negative 4 from the right. So we go like this, we put a little arrow, and we look and we say, all right, we're coming in to a value of 2. So that is 2. So I hope that this makes sense of what limits are graphically, when a limit has a value, when it is the value of the function, when it's DNE, and the difference between a left and a right limit and all of that notation. And next, we're going to do functions. See ya. Thank you very much. Bye.